Video, we're going to talk about how to find the area of a regular polygon. Let's start with some definitions. First of all, a regular polygon means a polygon where all of the sides are congruent and all of the angles are congruent. So this picture on the left, we have a regular hexagon where every side of this hexagon is the same length and every angle of this hexagon is the same measure. All regular polygons can be inscribed in a circle, or we can say a circle circumscribes the regular polygon. And so the center of the circle that circumscribes that polygon is called the center of that polygon. So right in the middle of that polygon. And then that's how we also get the radius of a polygon. It would be the radius of the circle that circumscribes the polygon. Or in other words, in a regular polygon, from the center of the polygon to the vertex of a polygon is considered the radius. So a regular hexagon would have 6 radiuses or radii. PN is a radius. PM is also a radius. PQ is not a radius. PQ goes from the center of this circle or center of the polygon and is perpendicular to the side of the polygon. That's called the apothem. The apothem is always perpendicular to the side, so it makes a right angle, and it's always going to be right in the middle of this side. So MQ and QN are also the same length. So those are some definitions to get us started. Also, we have angle MPN or angle NPM, which is an example of the central angle. So it's a central angle of that circle, also the central angle of that hexagon. So if I have a square right here, the center would be about here on that square. So remember, squares are a type of regular polygon. A radius would connect the vertex to that center. That's an example of a radius. There are 4 radiuses total. We could go to any of the 4 vertices to make a radius. That's another radius. And then the apothem goes from the center down to the center of the side and is always perpendicular to that side. So that would be an example of an apothem. When we draw in the radiuses or the radii, we know that a circle is 360 degrees total, and these are central angles. So ignore that apothem for a second. We have 4 central angles. They are all congruent to each other, and they are the 4 central angles of a circle. And so they add up to 360 degrees. So each one of these would be 90 degrees. And then if I draw the apothem in there, now this is 45 degrees because the apothem is always right in the middle of the 2 radii. So if we go back over on the left and look at the hexagon, a hexagon has 6 radiuses, and if they all add up, if all 6 central angles that are created add up to 360 degrees, that means, let me go ahead and draw another one here. That means each central angle is 60 degrees, since there are 6 total, and they all need to add up to 360. And so if I draw the apothem in there, that means each of these is 30 degrees. So that's just to kind of help set us up when we go to find the area here in a minute. So here's another setup question. We have a pentagon this time. It's a regular pentagon. So let's practice finding some angle measures to get started. The measure of angle AFB. AF is a radius and FB is a radius. We know that there are 5 radii in a regular pentagon. And since there are 5 and they're all the same and they all need to add up to 360, each one is going to be 72 degrees. So angle AFB, because that's a central angle, is 72 degrees. For AFG is being cut in half by this apothem, and so that's going to be half of 72 degrees, or 36 degrees. And then angle GAF, of course, right here, GAF, since we have a 36 degrees and a 90 degrees, and all 3 angles in a triangle need to add up to 180 degrees, that means that final angle would be 54 degrees. So let's get to the big hitter, which is finding the area of a regular polygon. To find the area of a regular polygon, we use this formula. The area is 1/2 of the apothem times the perimeter of the polygon. So in this figure over here, we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. It is a regular nonagon. There are 9 sides. We don't know, we can't find the perimeter right now because we don't know what each side length is. We will have to find that. And we actually don't know the apothem either on this one. So we're going to have to find both the apothem and the side length in order to use this formula. Should have started off with an easier example, but we're just diving right in here. So if we look at all of the radii, there are 9 total, all adding to 360 degrees. So that means each one is 40 degrees. So that means when we draw in the apothem over here, each one of these is going to be 20 degrees. So let me draw this little triangle out to the side. Right there. So I have the apothem, the radius, which is 4. We have half the side length right here. And we know that up here it is 20 degrees. So if we know we have a right triangle, 20 degrees, we don't have enough side lengths to use the Pythagorean theorem, but we can use trig here to find the missing side length. So let's start by finding the apothem. To find the apothem, we know the hypotenuse. The apothem is the adjacent side, so we're going to use cosine. Cosine of 20 degrees equals apothem over hypotenuse, adjacent over hypotenuse, a over 4. So the apothem is 4 times cosine of 20 degrees. And let me do that real fast. I get about I'll write to the nearest tenth, about 3.8 I'm getting as my apothem. So let me erase this. And 3.8 is that side length. Now to find this, I can use the Pythagorean theorem, or I can use trig again. This is the opposite side. So if I use trig again, this time I'm using sine of 20 degrees equals opposite over hypotenuse. So I'm going to do 4 times sine of 20 degrees. And I get 1.4, approximately 1.4. So this little guy is 1.4. Why that's helpful is if this is 1.4, ignore that, then the entire side length, each entire side length would be 2 of those, so 2.8. So if this is 1.4, then a side length is 2.8. And if the side length is 2.8 and there are 9 side lengths, then the perimeter, running out of room there, perimeter is 25.2. So to use the area formula, we needed the apothem and we needed the perimeter. Now we have both of those things. So when I go back up to the formula, the area equals 1/2 apothem times perimeter. So 25.2 times 3.8 divided by 2, we get about 47.9 if I'm rounding to the nearest 10th units squared. That was a doozy. That's about as complicated as they come. Let's see if I have an easier example on here to try. Ooh. This one is easier. So here we have a pentagon. We're assuming it's regular. It doesn't say so, but let's assume it. So we've got 1/2 times the apothem times the perimeter. I can't find the perimeter yet because I don't know what the side lengths are, but this time we can find the side lengths a little bit more easily. We do know the apothem is 6.5, so I can plug that in. So when I go to find my area, I just need to figure out what the perimeter is. So perimeter, we need the side length for that. We can start by finding half of the side length using the Pythagorean theorem. We'll call this x. X squared plus 6.5 squared equals 8 squared. So if I solve this, I'm getting x squared is equal to 21.75, which means x is about 4.7 if I'm rounding to the nearest 10th. And so if x is 4.7, then that means the whole side length is 2 of those, 9.4. And if each side length is 9.4, and there are 5 of them, then the perimeter is about 47. And that's what we need in order to find the area. 1/2 of 6.5 times 47 is about 152.75, or 0.8 if we're rounding to the nearest 10th units squared. Let's do another one. So same idea, 1/2 apothem times perimeter. This time we can find the perimeter easily because we know the side length is 7. And perimeter, we're going to add all the side lengths together. It's regular, we're assuming. So they're all the same. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 side lengths. Each one is 7, so that means our perimeter is 70. So then to find the rest of the area, we need the apothem. So I'm going to draw that in. Here's my center. Here's where the apothem is. We'll do red for apothem. Now, when I make my little right triangle right here, I don't know the radius. I do know that this is 3.5. But I don't know what the radius is, so I can't use the Pythagorean theorem here to find the apothem. What I'm going to have to do is use trig again. I'm going to draw that triangle a little bit bigger. So I need to find that angle measure up here at the top, up there. So this is a decagon. So if you were to draw in all the radii, each one would be 36 degrees, because there are 10 total and they all have to add up to 360. So that means this is 18 when it got split in half by the apothem. So if that's 18 degrees, then we can use trig. In this case, we're going to use opposite over adjacent, tangent. Tangent of 18 degrees equals opposite over adjacent. Or if we solve for the apothem, it would be 3.5 divided by tangent of 18. And that is about 10.8. The apothem is about 10.8 if we round to the nearest 10th. I changed colors on myself. 10.8 for the apothem. So if we do 10.8 times 70 divided by 2, we get our area as about 378 units squared. And that's a few examples of how to find the area of regular polygons.